All right, so we are in the packet here for 9.7 and 9.10, and we're on packet part D, as in dog. And this is going to go through 5 questions here that are on FRQ exams. And you can notice here that, we have the question copied and pasted, and then this is just an explanation of what you should be looking for. So if you're reading this on your own, you want to stop the video and just look at it yourself. Maybe you can skip some of these and you understand what it's referring to just by the reading portion. So looking at the question here, the function f has a Taylor centered at 1. And sometimes they'll call it a Taylor centered at 0, which is technically a Maclaurin, but it's the same, again, a rectangle square concept here. That converges to f and x is the interval of convergence, for all x in the interval of convergence. It is known. So they start giving you some information here, and then they give you the nth derivative of f at 1. So they give you that sort of that sigma argument here, just in a different form. And they say that that's what you would use for your second, third, fourth term because you already have the other ones in front of you. So write the first 4 non-zero terms, and they're going to specify non-zero, especially if you're thinking your sine or your cosine, where maybe the first term is a 0 or every other term is 0. They want to make sure that you have some data there to show that you know what you're doing. So if I'm going to have my Taylor, all right, a lot of people are going to go, so first 4. So some people are going to go t sub 4 of x. So I know that my first term here is going to be a 1, right? Then I'm going to have my derivative at 1, which is going to be my 1/2. All right, and then I'd have my x minus 1 because I'm centered at 1 to the first power over 1 factorial. And then I would have to go to the next one here, right? So I'd have to go with my form here. So then if n is 2, then I have my negative 1 to the n squared. So that's a positive 1. I'd have 1 factorial over 4. So I have 1/4 x minus 1 squared over my 2 factorial. And then I would go to the next one. And I'm just using this structure here to go to my next one. Okay, so now if n is a 3, now I've got negative 1 to the third. Now I've got 3 minus 1 factorial, so I've got 2 factorial over 2 cubed. And I don't know, maybe some people want to simplify that. Maybe you don't. That's really up to you. But I know it's going to be a negative 1. I'm going to have a 2 on the top, and I'm going to have a 2 cubed. And same, that's all representing my coefficient term, my a sub 3. I'm going to have my x minus 1 cubed, and I'm going to be over 3 factorial. Just like anything we've already talked about, okay? You cannot have complex fractions in your final answer. So you're going to need to go ahead and simplify these things out. So then my t sub 4 here is going to be 1 minus, I guess there's no reason to put that coefficient of a 1, so we'll just do x minus 1. I'm going to do the power here over 2 plus, I'm going to have my x minus 1 squared. You can see I've got 2 factorial, which is just a 2 over 8. I'm going to have my minus 1. I've got 2 over 2 cubed. Those would simplify. So this is really a denominator of 4, which is going to kick down over here. So I've got 2 times 3 times 4. So then that's 6. That's 24. So then I've got my 24 x minus 1 cubed. Okay, so they want the first 4 terms. Okay, so that's what I have. And the general term. Okay, so quite honestly, you're going to get 2 points for this section, and you're going to get 1 point for this. So then this is where you would go plus dot, 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 and then do your plus. So then I would have, I'm essentially going to have this here. All right, so I'm just going to drop that 2 to the n to the denominator because that's where it's going to go. And I'm going to have my n factorial down there. I'm going to have my x minus 1 to the n. All right. It is important that you do the dot, 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 and you have to realize that that's just your nth derivative. Just put it in there so that you don't have a complex fraction status. So yes, this would be out of 3 points, and we're going to go on to the next question. right, again, we've got the question form here. So a function has derivatives of order x equals 0. Let my polynomial sub n be the nth degree, about 0. It is known, okay, so they're going to give us some information here and here. Show that my derivative at 0 is equal to 2. Okay, so how about we build it first? So if I evaluate at a half, that answer is -3. So I got to think about that first. So I'm going to end up taking, I'm centered at 0. So then I want to take my first derivative and I want to evaluate that at 0. I'm going to be over 1 factorial. And I'm going to be x to the first. And I'm just going to write out a couple here. Okay, so then if we have, it is known, so that tells me, okay, so I'm looking here. So if I wrote out P1, so P1, and I evaluate at a half, the -4 is going to be there. I'm going to have my derivative evaluated at 0 over 1 factorial, and then I'm going to have to evaluate at a half, so my half is going to go in for x. And they're telling me that this has to equal -3. Okay, well, if this has to equal -3 and I'm going to solve, right, I can add 4 to both sides here. So that tells me my derivative evaluated at 0 times a half has to be a 1. So then my derivative evaluated at 0 has to be a 2. And it's a show that, right? So it's true. It has to be true. So you're kind of just going through those steps there. And again, this is where some people don't know what to do, so they put a check mark, which is fine. All right, now moving on to B. It is known, again, we got a second derivative evaluated at 0 is -2/3. And clean up that space there. And my third derivative evaluated at 0 is 1/3. They want me to find p sub 3. So then p sub 3. All right, I know the first term here is a -1. So I'm going to use this information. I've got no reason not to. I solved for it in part 1, so I'm going to use it in part 2 here. So then that tells me that I'm going to have a 2x over 1 factorial. So now if I have my second derivative evaluated at 0 is a -2/3, and I've got my -2/3. I've got my 2 factorial. I've got my x squared. I've got my positive 1/3. I've got my 3 factorial, and I've got x cubed. And again, they do not want you to have complex fractions, so we're just going to rewrite over here. So this denominator of 3 would get kicked down, but then these two 2's are going to simplify off. So I'm going to use a minus sign here. So I'm going to have a minus x squared over 3 plus, and now this 3 is going to get kicked down over here. So I really have a 2 times 3 times 3 situation. So that's going to be an x cubed over 18. And I'm stopping there because they wanted me to do the 3 terms. So I'm not doing a dot, dot, dot. I'm not doing the nth term. Okay, that's not what they asked for. Just give them what they ask for. Don't do more. And you're going to be fine. All right, D, again, we're talking about what you need to memorize. Okay, when we get to 9-10, there's going to be a long sheet. If you look in the book, there's a long sheet. You're going to want to know those because the questions are going to be manipulations of these basic ones. Okay, or look, there's going to be combinations where you're multiplying them together, but you're not going to recognize the pattern unless you've seen the original pattern. Okay, so now we've got our Maclaurin series. They're giving us the sigma notation. They're giving us the term-by-term expansion. Okay, right, here's my sigma. Here's my terms. Converges, absolute value less than r, where r is the radius. Okay, still no question, right? This is all of the facts that they're going to give us. Now here comes the question. Write down the first 4 non-zero terms for the series for E. It doesn't have anything to do with what we have. So then if I have my E, right, I'm going to go approximate over here is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Okay, and that's centered at 0. Okay, so I did that part. Use the Maclaurin series for E to write a third degree Taylor G function, okay, which is going to be E times F here. Okay, well, I got to figure out what F is. Okay, and F is the one above. So I already have my E, so let's figure out the F. And again, let's see, and it says Taylor about 0. But we want to get a third degree, so I've got to get to that third exponent, which is similar to what we have here for e to the x. So I can see they gave me all 3. All right, so they gave me all 3. I'm just going to write them down. That wasn't too bad. So they want my g of x to be the product of E times F. Okay, so now you got to consider your order of how things are going to be multiplied together. So if you want to consider this a parentheses here, maybe we should do a rewrite here. So I've got my 1 plus x squared over 2 plus x cubed. Let's call that a 6 just to make it cleaner instead of the factorial notation. Then I've got x minus 3 over 2 x squared plus 3x cubed. All right, so if we're going to go distributive property, I'm going to have an x for the first part, and it doesn't matter. Whatever I multiply next is never going to have another x. So I know that lowest degree term has to be an x. When I multiply the next one, I'm going to have a negative 3 over 2 x squared. And then when I do the next one here again, I'm going to have a positive 3x cubed. Okay, so now when I go multiply the next grouping, I'm going to have an x times an x, which is a 1x squared. So I have to add up those like terms. And then I'm going to have to multiply, excuse me, x times the minus 3 over 2 to get my minus 3 over 2x squared. This was an x squared. When I multiply by x, it's going to be a cube. That's why I put it in the cubic column. And if I multiply one more time, I'm going to have a 4th degree. Okay, but it says they wanted us to have a 3rd degree, so I don't have to do that. So now I just need to add up these like terms, and then I'm going to have my 3rd degree. So I've got a negative 1.5 plus a 1 gives me a negative half. So then I've got a let's just call it, no, let's just write it down the way we said it. Negative a half x squared, and then I've got a 3x cubed minus 1.5 gives me a positive 1.5 x cubed. So those are my 3 terms. You just had to consider what your like terms are going to be. There's no reason to multiply the rest of it out. All right, here's our last one here for part D. Let f be sine of x squared plus cosine. The graph of y, the 5th derivative of x, is shown above. I don't see that anywhere. So we'll have to see what's going on with that one. Write the first 4 non-zeros for sine. All right, well, sine is going to be odd. Well, we're going to approximate, so let's just call it equals. So if it's going to be odd, I've got x, and then I've got to switch it over. So then I've got the cubic over the 3 factorial plus the 5th over the 5th factorial minus the 7th over the 7th factorial. Okay, then write the first four non-zeros of Taylor of sine of x squared. So then if I go to sine of x squared, wherever there's an x, I'm going to replace it with a square. Wherever there's an x, I'm going to replace it with a square. Wherever there's an x, I'm going to replace it with a square. So if I clean that guy up, if you have x squared cubed, you multiply them together, so you get the 6th. And then I have the 10th. Those are my factorials, minus the 14th. All right, so I like those two. So A is done. Write the first four non-zero terms for cosine. All right, well, cosine's even. So if it's even, I'm going to start with 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Use this series and the series for sine of x squared found in part A to write the first four non-zeros of the Taylor of f. So they want us to group them together. All right, so then if I want f of x then, to save me the writing, so I just need to add them up. Okay, so same idea. I'm doing term by term addition here. There's only one numeric term. I have an x squared and I have another x squared, and this is a half. So if I have 1 minus a half, I still have a minus a half. Okay, so then those guys are gone, and I want to double check. First four non-zeros. So now I've got the 6th power and I've got a 4th power. Well, those aren't like terms, so I'm just going to write down the 4th power. So my 6th and my 6th go together. So maybe I need to think about, I've got a negative x to the 6th with a 6th denominator, and I've got a negative x to the 6th with a 2, 3, 4, 5, 6 factorial. So, okay, so noticing what we have here, right? This is, I have a 6, and this is essentially 6 factorial, but if I remove the 6, that means I need an additional 5 factorial to make a common denominator, which means I need a 5 factorial on the numerator there. 5 factorial is 120. So what I really have here is a negative 120 x to the 6th over 6 factorial. Okay, so then if I've got a negative 120 and a minus 1, that gives me a negative 121 over 6 factorial x to the 6th. And I have my first, second, third, 4th term. So now I am done with that question. All righty, that is D. I'll see you on the next one.